Hello everyone, it's February 23rd. Yep, I got here earlier today, which is great. Great. Got here early. So let's get down to the business. Cheapest flights within K stops. There are n cities connected by some number of flights. You're given an array of flights where flights I is from to price indicate there is a flight from city to city with a cost. You are also given three integers, source, destination, and k. Return the cheapest price from source to destination with the most k stops. If there's no such route, return -1. At most k stops. Okay, so I feel DP, right? This is like DP. There will not be any multiple flights between two cities. And a source not equal to destination. Okay. So source is 0. Destination is 3. And I want to have at most one stop. So yeah, that's the one. That's the only one you can go. Oh, not really, because you can go here. Okay. So is this Dijkstra? So you have the source, you go to destination, and you want the cheapest price with the most k stops. So Dijkstra will not respect the stop, right? But you can put that as an additional constraint, which means you go from this, right? So Dijkstra will be, you start from 1 and you put the next possible option, all of them, right? You put all of them into it and you pick the lowest out, and then you push everything in, and then you get it out, and then and you update. You update the value, the cost to reach each state, to reach each node, right? And then you keep doing this, you keep pushing out the smallest, and eventually you will reach your destination. So once you reach your destination, you probably need to also keep track of the number of stops that's required to get there, right? The number of stops are required to get there. Now, if it's too much, then what do? Then we basically just, try. Yeah, so you already used Dijkstra to get there. But then what? Then there will still be stuff in the queue. So what do? You keep popping things out. Yeah, you just keep running Dijkstra. You keep running Dijkstra because let's say you already get to destination, but they have too many steps, right? They have too many steps. Then what? Then we say we keep going, because everyone already has the lowest cost to reach there. And if we keep running, is just going to be from the destination. You keep going out. That doesn't seem right. K is 0. No stop. Source is 0, destination 2. You should go 500. Yeah. So if you go Dijkstra, this one will pick 1, right? And then from 1, you go to 2. And then it's not right. Then what you do? Well, this is also on it, right? The 0 to 2. that's also on the queue. So if you pop, I have 2, I have 500. Yeah, so you have all of those on the queue. So you just pop them out. All right, okay, you pop them out, and then what? Right, and then what? You pop them out, and then you check with the previous, and your current prices. So you need to know that it's a reset, right? It's a reset. So when you save it, it has to be a little bit more. It needs to be its price and also the iteration, right? It's like an ID. It's in the current search, because if it doesn't work, we need to go to the next search. So if the ID is different, I have to use the next search. If the ID is the same, I keep track of the lowest. Yeah, because the smallest is already gone. Okay, I can give that a shot and see if that works. I also need to check, because I forgot again, how to do, I don't remember. And the priority queue will be, it'll be 2 things, right? It'll be 2 things. Priority queue. I need its price, and also need its the node, the number on the node. I hope I can just put in. Do we need to do something about this? We do, because we start from 0. I need to know. So I need a way to also handle the not the flights, and to handle the graph. So I need a graph, which will be I'm not using map. I think because flights, how many is n flights? Flights could be huge. Oh, but n is small. A list of, yeah, I cannot do a list of, yeah, let's just do map. I don't think I can do a list, an array of lists. I don't think that's possible. Actually, I'm not sure. Can I do array of lists? Maybe I can. Array of lists. Can I do it? So we say array? No. Array of list. So basically the list integer. Well, it's each one is gonna be a list of list. List of this. This? That's impossible. Graph. Oh, it might be possible. No, it's actually I'm not sure. An array of array list. Is it possible? Oh yeah, you cannot. Oopsie doozy. That's a no-go. Alright, so this is not good. Alright, we have to use map. So map integer, and then it's gonna be a list of int. This is our graph. Okay. Oh, for lights. So source, destination, price. Source, destination, and price. So when say graph dot get, no, put. Okay, so f0 is source. Okay, and then we say graph dot get or default. Get f0. Our default is new array list. Right? Dot add. So what do we add? A new int f. This is the end, and this is the price. Right? The array, the inner array, right? Inner array is destination and price. Okay, so that's to build the graph. Okay, so we get the graph, and then we need to run Dijkstra. We need to run it multiple times, and then we will get, and then, but I say it could be impossible. Okay, so we need a queue. Okay, so we need a queue. So we say priority queue, PQ. We can call this queue. No, priority, what's the type? It's gonna be an int. Queue equals a new priority queue. Okay, and then we're gonna put source and the price in there. So queue dot add new int source and 0. Okay, the price. So each element is node and price. But before doing that, we also need the int prices, new int n, right, and number 2. So it's a price, and also, so each element is price and iteration, right, iteration. And everybody needs to be very, can I call? That's fine. We can just say for int I0, I smaller than n, I plus plus. Each one, we say prices I, I probably need to do this. Prices I equal I0 is the price. So we need to put that into a max value. What do you think is a max value? So we need to find a minimum. And a max value, price is this, right? So each price is this. How many in total? And so 100. So 50 times 49, right? That's the maximum. So basically 50 times 49 times 10 to the fourth. That's the maximum. So we can do 1, 2, 3, 4, 5, 6, 7, 8. 300 million. 300, 1, 2, 3, 4, 5, 6. Okay. So this is some max value. And prices I1 iteration will be 0, right? Because we are on the first iteration. So that's the price. And then we have the priority queue. And then we have this, and then we have iteration is equal to 0, the first iteration. And then while q dot is empty, right, if q is not empty, then we just keep running this. All right. So q is not empty. I'll grab the first one out. We say int element equals q dot poll. Retrieve and remove the head and returns null. Okay, yeah, we do poll. And remember, this is node and the current price. Then we need to find its children. Actually, no. I think this is this should be while q dot is empty, while q is not empty, and q dot peak. Okay. Peak 0 is the node. So we need to say, oh, this is going to be, damn, because we need to know. So we need to pop, right? We need to pull the ones that's bad, that doesn't match, right? That doesn't match, which means if they're the same and it's not the same as, then we will pull it, right? We'll pull it and pull it until we find one that is the same. Yeah, that's the same, which means the same iteration and it's the same. Okay, so stop. Then we'll pull it out. Then we run it. Okay, so what if the iteration is different? Well, if the iteration itself is different, then we will, yeah, we'll pull it because we are in a different iteration. So, okay. So what we need is, say, prices. Okay, prices, I can do this. This is a node, right? So the prices 0. So that's the price. If this is not equal to q dot peak, you know what? I think we have we can do it better. Let's do it better. Okay. Can say int node equal to q dot peak 0 and int price p equal to q dot peak 1, right? Oh, we get this too. Then we say if iteration, right, is not equal to prices node 1, or p is not equal to prices, yeah, I just call it price, right? It's gonna be price if that's not equal to prices node 0, any of these two, right, then I say q.pull. Wait, take this one out. Else break. Right, else break. Okay, now we break. Now we do another pull to get the element. Okay, and then we say int node is element 0 and int price is element 1. Okay, and these live in different scope, that's fine. And then we need to go through the map. Okay, so for int child element of graph dot get all default node, and this should be collections dot empty list, right? Node or collections dot empty list. Now I have child element, and for child element we'll have its destination, which is, we can call it, oh, you're forgetting another thing, the number of stops. Oh my god. Yeah, well, we deal with this. Well, we have to deal with this. So iterations, right? And then we need to do and you didn't do int num stops. Okay, so this is the first one come out, and then node and price. If node is equal to destination, right, and num stops are smaller or equal to k, then we return price. Right, this is the current price to reach here, so we're done. Otherwise, then we have child, right? Child shall equal to child element 0, and edge cost is child element 1. Okay, then what I can do is the current price, right? Because I have the current price, then updated price, right? So we can actually do updated price. We can do updated price shall equal to child this plus price, right? So update price. Then we say if, okay, current iteration is not equal to prices child 1 or updated price is smaller than prices child 0, right? So right now it's better than before, then we need to update. Then we say prices child 0 equal to update price prices child 1 equals to iteration. Okay, then we need to push that into the queue. So queue dot add new int. For the queue is node, which is child, is updated price. Right, so it pushes in, then we're good. Then we go to the next one, we push all them in. Right, we push all them in, and then once we're done, Actually, this one I need to change. I just realized something. Okay, so it's equal to, right? Then we say if this, then return price. That's good. Else, if number stops are larger than, then num stops. Oh, where do we reset? Right? Where do we reset? Because if you pop something out from, oh, you need number of stops as well in the, you can't just keep adding. You need to know which stop you are at. Oh my god. So for the, this one is 3. So node, price, and number of stops so far. But I don't need this. So I need this. This is 0. Right? Iteration, I still need iteration because I know this is bad. So now I'm going for the second iteration. Right? So first iteration is down and it's no good. Oh yeah, how do you do the second iteration? Or you just ignore it. We just keep going. But if you keep going, how do you know you need to update? Right? We kind of use iteration for that. So the first iteration is done, and then iteration goal plus equal 1. So whatever is coming out right now is the second iteration. We still need iteration. So for this price, I only need these two, right? I only need these two. But if I can get, if I already find out that the current way has more yeah, well, what if your current, we just don't go all the way to the destination, like halfway through I already see that we are going more than we need. Then what? Now I think we have to hit it, right? We have to hit it first, because otherwise, how do you know? We have to hit it first, right? And then it fails, and then the kind of signal the failure of the best scenario. Then we try something different, right? Then we try something different and then see if we can get a better deal out of it. Yeah, I think we should just keep running this. Yeah, we just keep running this. Yeah, iteration. So yeah, we do that, blah blah blah, and then we do this q, and I do need the num stops, right? It's element 2. Again, if node is destination and num stops is smaller than this, I now return price. Otherwise that simply means it's not working. So iteration need to plus equal 1, right? We need to add iteration. So we're going for the second one, right? It's the second iteration. And it's starting from your destination going out. From your destination going out, right? From your destination going out. And eventually, well, because we still have something on the queue. Oh, hold a second. Then, yo, yeah, you can't. You have something, you already popped out all the other possibilities. Because initially you get everybody in, right? And then you go, and you fail, right? And you fail. Then you basically have to restart. So all you know is this edge cannot be used. Huh. This edge cannot be used. Like, okay, so we start again. We start the Dijkstraat again, right? And What do we do when we start a Dijkstra again? Do we put a note on this? Or can we remove these edges? Because if we have a certain path leading from source to destination and it's the lowest cost, okay? So we have a path that is lowest cost. But that path has more stops, right, than we want. That means we need to go a different route. And a different route might still use, right? Might still use the same thing. So you cannot rule it out. Then I don't like how? How? So Dijkstra's on price, but we need both price and the number of stops. So if we go with price and we will hit a point where there are more stops. Right? We hit basically, it's not destination, but the stops is already too much. So in that case, we backtrack. Backtrack? Are you sure? What are you saying? That we go through the whole thing? I mean, maybe. We just backtrack this thing. We traverse the whole thing, right? Each edge we visit, but each edge might be visited more than once. Or we can say from a node, right? From one node, I have the cost of reaching. Okay, so from one node, I will return the minimum cost of reaching the destination. Or just the cost of reaching the destination from one node. Okay, from one node I'll get all the cost of reaching the destination with the number of stops needed. So we have the start, then we branch out. Okay, so from here I'll find I still feel it should be Dijkstra, right? Let me think again. If we use Dijkstra, why we cannot use it? Need some snacks. Dijkstra, we can find the shortest, the lowest cost, right? But could be too many steps. How to update it? Do we that's what I'm saying, like, do we backtrack it? Oh, Oh, hold on. Maybe just BFS. Because we cannot go beyond K. We just BFS it. We BFS and then keep track of the price when we hit the destination. No need to do extra. Oh man, these nuts. Share what link? Link of the problem? Well, just go to LeetCode.com. It's the daily challenge problem. It's on top of the problem list. Alright, I think this is just a BFS. Because you can have at most K stops, right? So you just BFS at most K plus 1 times. Right? K plus 1 times. And then just keep track of the current price, the lowest price. And when you hit the destination, after you go through K plus 1 times, then you return, you see what the destination is. And yeah. All right. Okay. Yeah. Link. Actually, I can do that. Here is the problem link. I'll put on the chat. All right. These mixed nuts help me figure it out. Yes, I am from China. All right, so let's do this. I basically have to rewrite everything. No, not rewrite everything. The graph is still good. All I need to do is to... Yes, that's correct. I'm from China. The graph is correct. The prices, I don't need this. I think it's just a one dimension would be enough, right? It's one dimension. Okay, one dimension, and each element is just the lowest price, right? Lowest price. And I think you can use something called arrays dot fill. Yes, prices. I'm going to fill it with, well, hello from Peru. Hola from Peru. Prices will fill with this giant value. 1, 2, 3. Okay, so then what we're gonna do, no priority queue, so we're just going to do a queue. And do they have a queue? I don't think they have a queue though. They have a deck. Yeah, we use a deck. Deck of we want a node, right? That's all we want is the node. Yeah. And the price, right? So it has to be two things. So it has to be queue new array deck. Is that array deck? Yep, array deck. Okay, so I don't need, I need to say each element shall be the node and price. Current price, right? Current price. All right, don't need this. Okay, so the start is the source and current price is this. Good. I probably need to change this one as well. I should say prices source shall equal to 0, because the source price is always going to be 0. All right, so this is good. We don't need this. We can do this. All right, let's just delete whole thing. Okay. Now what? Now we just do, we need to know int number of stops, right? So num stops, or I can just decrement k, right? I can just decrement k, and need to do k plus 1, right? Number of times. So I can do k plus plus and then say while not this and k is larger than 0, so k cannot be 0, right? Okay, then we can say int, right, element equal to your q dot poll, okay, dot poll, and then we have node is element 0 and price, current price, right, is equal to element 1, and then we're gonna go to all of its child, right, all of its child. We might need to, whenever we are at the current and then I need to update its price, you know what, if I update its price, I don't even need to do this. I can just do it here, right? So basically say prices node shall equal to math.minimum prices node and the current price, right? So that's just the minimum number, the minimum price for reaching the current, right? Reaching the current, and then we just keep. Actually, you shouldn't, right? You shouldn't. Wait, hold on. So as I'm reaching, right? As I'm reaching, it's, you know, it's a one stop, right? It's like one stop. I hit a price like this. It should be this number of numbers. Okay, hold on. This is also not right. It should be a 2, right? It should be 2. And because you have the current node with a number of stops, like at one stop, like if you are the first stop, what's the minimum price to get to you? The second stop, what's the minimum price? And at most, you can have k stops. So I'll do n and k plus 1, right? Because we can do k. K can take 0 and 1. Okay, so I can say price is. So I say prices ij, okay, is equal to the lowest price to reach node I with it being the jth stop. That makes more sense now. Well, the problem is not simple for sure. It's medium. It's like a hard medium. That's how I think of it. It's a hard medium, because median has a very large range. You have a very easy one, you have a very difficult one. This is towards the difficult side. Okay, so we have the prices now, and then we can do, so I have this, and I know, the number. Okay, I cannot use this trick. I have to say number of stops. Okay, number of stops start with 0. And then I shall say here, the number of stops should be smaller or equal to k. Okay, so number of stops cannot be more than k. So when we start with this, and then we have a node, we have the price. Okay, then price, the current node, and we need its number of stops, right? We need its number of stops shall equal to the minimum of the current node with number of stops. Oh, holy crap, this one is not right, because it's a 2D array. I want to fill everything. Actually, I don't know. Number stop fill, not number stop fill, arrays fill 2D array. Can I fill 2D array? Is that possible? I have to use this. Okay, that's okay. That is okay. So for int row of prices, right? And then I just do this. I do arrays of fill. This is a row with this value. Okay, so that's fine. And then let's put some, let me put this one here, so make it look nicer. Okay, so I'll do paste this. Okay, and then here is the deck, right? And here is the BFS. All right, so I say blah blah blah. Yeah, that's right. So the node with the current number of stops, and we want to find its minimum, and then it's be this, and then the current price. We just keep the lowest, and we'll keep going through. And in fact, if we have reached, we cannot do anything. We have to go through all k, because if you reach your destination early, that doesn't mean that you have a lowest price. So yeah, we'll basically do this, we update this, and then we have to go for the child. Okay, so it will be int child element of graph dot get all default node. Default here is still collections dot empty list, right? Yes, empty list. Okay, so now your child, we have child is child element 0. Okay, and the int, what is this? This is the edge cost is equal to child element 1. Okay, so now you need to put a new one into it. So basically what you want to do is saying q.add new int, okay, of, you put your child in it and the current price, which is this price, plus the edge cost, right? Your price, actually I didn't call it price, I call it current price. Right? Makes sense. Yeah, the current price. Yeah, I think this one, my editor is not recognizing this. Oh, my job, my software engineer, my job. Yeah, I am a developer. So Q will add this, and then we go through everything. We add this in, right? We add this in the current price. We add it in, and we also have the current stop, which means something might get visited twice. Yeah, okay. So once we're done, right, we hit every one so far, right? We hit everything. Oh, that's actually not. When are you going to update? Ugh. Right? You can't. You have to. All right. Because I need to know when the number of stops need to increment, and that's usually not how I do it. How am I supposed to do it? Well, you need to count. Yeah, I don't like it. I don't like this way of doing. Actually, I don't know how you know you finished the current. Well, we can count the number, right? We can count the number on the queue, and once it's done, and then you go for the next one. So you only go through that number. Do I like that? I don't like that. I do not like that at all. I think I will not use a deck for this. It's easier for me to reason if I use as simple as a list. Yeah, I think a list for me is much easier for me to reason with. So I use array list. Okay, I use array list. And I can still call it Q, it's fine. And then I don't do this. What I do is I will do a dummy. We can call it int again. Temp equals a new array list. Okay, and now we don't do this. We say for int element of Q, right? And then we do the same thing. So D7J. Okay, we do the same thing. Now we paste them here. I need a formatter for Java as well. Okay, I don't need this, right? So we go through the whole thing, and every time we push, we pop this, we do this, da 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 da. So this one will be temp, right? We temp will add this. So once we're done, that's why I say number stops plus plus, and then we say Q is equal to temp. I like this way of doing BFS. Okay, so now we're done. All right, we go through the BFS. Okay, now we get out. Then we need to go through the prices. Right, we go through the prices. So we find the destination and then go through it and find the minimum value, right? So we say int result is equal to the max. All right, so I think it will be easier if I do this. Int max is 300 million. Okay, then all the occurrences of this I can do a max, and here is also a max, and then for int p of prices destination, and then we say res shall equal to math dot minimum res and p. Okay, so now at the end we can say return is res equal to max. If it's equal to max, that means I never hit, right? I never hit it, so that should be -1. Otherwise I return res. Okay. Ooh, that is quite a journey. Let's give this a shot, see if it's right, at least with these test cases. Are you correct? Incompatible types. Madre mia, what the hell? Boolean cannot be converted. Boolean? Where is Boolean? I don't have a Boolean here. Okay, graph.put. Okay, this is fine. Graph.get or default. This is fine. And this is new array list. That's fine. And oh, I see. Yep, this is not right. So I should do, yeah, graph dot put if absent, right? I should do this. F0 if it's absent. I do new array list, and I say graph dot get F0, and then I will dot add whatever I did there, right? Whatever I did there, ci this. So I will paste it here, and I delete this one. Okay, try it again. Try one more time. All right. How is this one going? Oh my goodness, it's very bad. Holy crap. Wow, it's very wrong. My. It's all right. We have this many times. Okay, so what happened? I think this one's fine, right? And then I do the price. Price should be fine. K is 1, so I do 2. Okay, and then every row I set it to max. That's okay. And I have the Q, and I put source and the current price. Number of stops is 0. Okay, so it's here. And then I go to element in the queue, which is source and 0. Okay, I have source and 0 coming out. And then, oh, so you're telling me the number of stops should be 1 at the start. No, it is 0, right? So because when you reach here, right, that's number of stops is 0. Yeah, that's 0. So this is the first one in reach, and the number of stop is 0. Okay, and then the price basically is current price. Current price. Oh, did you forget something? Okay, this I'm updating, right? I'm updating. Yeah, this does not seem right. This should not be. Maybe you should update it inside here. You know? Inside here. Don't update in here. Because I get this out, right? And the number of stop, because I start with 0, and then I get number of stops here, and then I go. All right, so next time, this is when 1 is pushed in. So when 1 comes out, the number of stop becomes 1, but actually this should be 0. Yeah, that is the problem. Okay, so what we can do is I can set number of stops to -1. You know, but I think I'll screw up the first one. So I might as well just do it here, right? I just do it here. So instead of calling it this, I can say current price, the next price, okay? Next price equal this plus this edge cost plus current price, right? Edge cost plus current price. And once I'm done, I do this. So every time I go to the next one, I do this one here. So it's going to be child, number of stop. This is child, number of stop, and this is the next price, right? Next price. So I already handled it here. And then we'll do this child, and this is going to be the next price. Okay, so now the number of stops is correct. So child is 0. So when you reach here, that's a 0 stop. So you do that, right? You do that, and you do this and everything, and then you do stops plus plus, right? So once you go, okay, so let's try this one. See if this one's correct. Much better, much better. Okay, let's use all of them and see how this one. Oh. All right, we count to 5. 1, 2, 3, 4, 5. All right, let's go. And it's correct. I think we might have the solution. Let me just right here. So it's LeetCode 787. Use BFS directly and go for at most K levels. For each node with create a 2D prices array to record the minimum price each node can be reached given some number of reached at some number of stops. Okay, once the BFS is done, we check all the prices for the destination, right? Destination, and pick the smallest one, right? If the destination has never been reached within K levels of BFS, then return -1. So what will be the runtime? Stream stuck? That stream looks fine to me. It's still going on. All right, what's the runtime for this? Runtime. Okay, so to process the first one, okay, I have n and I have m, right? So m is the number of flights. So I can say om, right? This is to create the graph, and then this is, I have to go through n, okay, that's plus n, and then I have the BFS itself. So the BFS itself will go, so there's a number of edges, right? You have to go the number of edges, but I maxed out at k, so only k levels. Actually, I don't know what's the time complexity of like plus what. It's like k steps, right? K steps, but each step we don't know how many edges there are for each step. I put it like this. All right, let's see. All right, this problem, I tried it last time. Oh my goodness, a memory limit. Oh, this is unheard of. Oh, I used the same method before and it didn't work. Oh, memory. Too much in the queue, right? Too much in the queue. How? There's not that much data. There's not that much data, man. That's only n squared. Did you revisit? Yeah, I think I might revisit a node. But you have to revisit a node, right? Wait, hold on. Why would you revisit a node? Well, you revisit a node because it may, right? Oh, I know. Once you hit the destination, you don't keep going. Right? Once you hit a destination, why do you keep going on it, right? Okay, so that's the thing. So if you hit a destination, which means for child, and I say if child, right? If child, oh, I need to do all that, but we don't. So I add this, hopefully I can reduce the memory usage. Okay, these are still correct. Let's see if this one will be correct as well. Let's put this one in here. Oh, you're very welcome. Please do not error. Oh my goodness, errored again. Oh, well, it's been a while. How many did we go through? Damn it, not even half. A little bit over half. Okay, so we need a little bit smarter than this. Okay. Memory limit. What's the memory limit on this one? So another way to reduce memory usage is, I don't know. I mean, maybe this way of going through the queue is very memory intensive. I have no idea. I have no clue. Memory. I mean, are we going to the same? Okay, this is not that bad. Maybe we can just take a look. I don't think we can take a look at this. We start at we have 17 nodes. We start at 13. We'll go to 4 with 13 steps. Yeah, it's hard to analyze. So anyway, so we start from 1. I just think again with BFS, okay? We start with 1. But what if you BFS, you go back to this, yeah, like your BFS out, right? And then you will go to some nodes and then go back. We do not go back, right? If we go back, but what if you go back and it costs less? That's the thing, right? If you go back, you might cost less. You start from a place and you go out, and then you can go another place, go out, and then you can go back, and yeah, that might be cheaper, right? So you have to revisit the same node, but as you revisit the same node, if the cost, right, if the cost is higher, but isn't then that becomes Dijkstra, but slightly different, right? Slightly different. I think, hold on, I think here. So if I go to a child, right, with the number of stops, I say a number of stops, but if I have a better option, yeah, if I visit the same node, okay, with a higher number of stops, right, with a higher number of stops, and I shall only do that if that can bring the price down. If it does not bring the price down, then what's the point, right? I can reach it already with a lower price. That makes sense. Okay, so how are we going to do that? So you're saying that we need another one called mean prices, right? Mean prices. But then why do you need the number of stops? Why do you need for this to be 2D? Right? Why do you need it to be 2D? I think 1D will work, right? 1D just always keep the smallest price. And if you keep going and you can revisit and you'll, okay, yeah, maybe I don't need to be 2, right? I don't need, because all I need to know is the smallest price within the case steps, right? Case stops. And then within this, all I want is just to keep it as small as possible. So, all right, let me change it. Maybe this, the lowest price to reach node I, okay, within the BFS, right? So in that case, I would just comment out this, and just in case, maybe we need to revisit that idea later. So I say new int n, and then I say arrays dot fill prices with max, right? And then we do the same thing. These are all the same, and here we change. Okay, this one we change. What do? What we say is, if child is not equal to destination for sure. Wait, hold a second. But I need to update it. Okay, so I need to say if prices child is, or okay, I can say the next price, right? If the next price is smaller than price child, okay, if it's smaller than price child, that means I'm getting a better deal, right? Then I say prices child is equal to next price, okay? And then I say if child is not equal to destination, then I will also do, I will do this, right? I will do this, but only if it's not destination, because if it is destination, so we already reached destination, why do you keep moving? So this guarantees that we'll only move on if going to the current child give me a better price. And then once we're done, I can do this. I can just do, this is just gonna be prices. No, I can directly do it, right? I can directly do it. I can say return prices destination, right? Prices destination is equal to max. Okay, let's try this one. Is this gonna work? Oh, there's no res. Prices dst. We probably have to wait a little bit. 1, 2, 3, 4, 5. This one looks more promising. Okay, so use this a 1D array. Okay, 1D array to record the min price of each node during BFS, right? During BFS, we only progress to the next level, to the next node, if doing so can lower the price of reaching that node. Okay, so this can be deleted. I don't need this. And this is the Q is the same. This is the same. This one can be deleted. Okay, and yeah, I still don't know the last question mark. Okay, let's try this one. Come on, give me some. Yes, yes. All right, so it's better than last time, because you can see that was the performance of last time, 2023, January 25th. I mean, I already forgot how this one's done. And last time was a lot of struggle, right? Struggle for an hour, couldn't do it. I wonder if I checked the answer last time, so I can actually take a look at here. Did I check the answer last time? All right, so I Dijkstra this thing last time. I probably didn't check the answer. It took a long time. All right, I'm just gonna open all my solution from last time just to kind of take a look. So this is a Dijkstra, which is holy crap, look at this. I have 2 heaps. Nah. Why you use 2 heaps? Thank you. Yeah, it was good, but it took way too long. I don't know why you use 2 heaps. Because I was keeping track of 2 things at the same time. I don't know. That looks complicated. Okay, what's the other solution I used before? Oh, it is Dijkstra again without keeping track of the distance. Okay, so this one I need to take a look. It is Dijkstra. What about this one? BFS, the official solution. We only take the node that improves the pricing. Yes, so I got the official solution. Otherwise, there's no point taking it anymore. We use prices array to keep track of it. Yes, I think this is exactly the same as what I did. Exactly the same. Yes. Exactly. So this is exactly the same solution as the one I have today. But I mean, it's in Java, so that's very verbose. Okay, so that was good. What's this one? Updated version 1. Is allowed. No, this is the same, right? Yeah. Deck. It's the same. Pop left, city, price. Oh, you put the stops in here. I see. You put the stops in here. Got it. Yeah, I was thinking, how do you do using a deck? Yeah, you put the stops inside. That's how you do it. Okay, maybe this deserve another shot. Because I want to see, in Java, it matters a lot what data structure you use. Like in this one, I have to create a new array list every single time. So that brings the performance down. Okay, so if I can do just a deck, I think I can get better. And I can't believe I forgot. You should put the stop inside. Okay, this is a good one. What about this one? Ugh. Okay. So the Bellman-Ford. I think Bellman-Ford is the flow, right? Flow from one side to the other. Okay, I need more study. Wow, so 3 solutions. I understand this one because that's the same as mine. This one I need to study a little bit because I tried, right? I tried Dijkstra, but didn't work for me. And Bellman-Ford, yeah, I have to learn this. Okay, let's call it a day. It's a little bit long, but good question. Yeah, this is one of those good questions. Definitely reasonable, okay, in an interview. Definitely reasonable in an interview. And but in interview, of course, you'll get a little bit hint here and there. Yeah, you'll get there. I think the interviewer might say, yeah, just don't think about the extra. Let's just go BFS. Yeah, what do you think BFS will do? And then you start thinking BFS. And then he might also give you a hint saying, oh, what if, we don't go all the way down, we just go K levels. I think that's when you should click. That's when I clicked, right? Okay, I'll leave these 3 tasks tomorrow. Hopefully tomorrow is easier so I can finish it and then go through these 3. All right, that'll be it for today. I will see you guys tomorrow. Adios.